Yesterday, we posted a video about a Sandisk USB flash drive that came in for data recovery, and we were not able to recover data of the drive because I mentioned that the problem is from the chip itself. The whole flash drive is just this chip that you see here. That's the whole flash drive, and there's a USB 3.0 socket that's soldered onto those pads and to those 4 pins in the front. The drive itself only has a few components: 1, 2, 3, 4, 5. I measured all the components here except for the LED component. I did not have a reason to believe that the LED is faulty because the LED is blinking, it's flashing, and if an LED is shorting or an LED is bad, it would not flash. So we did measure all the components on here, and all of them measured good. Nothing stood out as being faulty. Today, I was reading your comments, and I do read comments. I read every single comment. And some of the comments suggested that the problem could be the LED component itself, the light emitting diode. Even though the LED is flashing, it's blinking, it's showing an indication that the chip is trying to read, blinking fast or blinking slow. So I do not have a reason to believe that the LED itself is bad, even though the thermal camera did show heat on this side of the chip. It did not show heat here, it did not show heat here, but it did show heat on this side of the chip. Others in the comments suggested, what if that LED is leaking, causing overheating onto that chip, and that's why the chip is freezing or it's not being recognized, so on and so forth. Today, we're gonna remove the LED and see if that makes any difference. If yes, great. If not, then at least we tried. We gave it our best. Now, I already desoldered the socket that we soldered on yesterday, VCC, D+, D-, and ground, but we're gonna solder the socket again, and today, I'm thinking, why don't we try another socket? Even though the socket that we worked with is good, it does not hurt to try another socket. We're going to be using this one here. I'm going to solder wires onto that socket, and we're going to connect the socket onto those front pads. We're going to be using 2.0. We do not care about those pins. The data lines here, those are used for USB 3.0. We can still recover data by connecting to USB 2.0. So let's go ahead and solder wires here. We're going to solder the wires from here. This one goes here, this one goes here, so on and so forth. We're going to have to flip it like this. And then we can attempt to see if that will solve the problem after removing this component here. Now this socket has the notches on the side, and it's going to come in our way of soldering. So let's just clip. We're going to clip. And when we are clipping, always put the thumb over, because if you do not, that small piece can go straight to your pupil. Bullseye. It happens. Even if you try to throw that piece in the pupil, it's not going to hit. But when you cut it, it's going to go straight to the pupil. That's how things work in this world. That's wire 1, and we're going to cut that wire from right here. And now we're going to do wire 2. I do not have that socket held by anything, so it's wobbling all over the place. It's okay, we only have 4 wires. And that's wire number 2. And we're done. We have 4 wires soldered onto the socket. And we are just a few minutes away from knowing if that drive will work without the LED component or not. I'm gonna post the video anyway. Now we flip the socket like this. And this drive belonged to a customer with ticket number 8539. We are in the 113959 ticket right now, so it's an old drive. Okay, I feel like we need more flux and more solder. The solder that we have on the pads is not enough. We want to make sure that we have a good connection. So we're gonna grab the wire from here and we're gonna apply more solder. More solder. And we're gonna apply more here. And we're good. And now we're gonna remove this LED. Maybe we can use our hot tweezers to remove it. Just like that. And what I should have done was measure that diode or that LED, right? The least we could have done was measure it. Let's go in diode mode. Red probe on top, black probe on the bottom. And I'm reading nothing. And if we flip the probe, I'm also reading nothing. I have a feeling that LED is gonna snap to the 9th dimension. And that's what we have right here. I do not know if you can see it. And we're gonna plug it in. We did hear the tone. I got a message to format the drive. I'm gonna unplug and replug and see what happens. It says you need to format the disk in drive E before you can use it. But at the same time, I'm getting a green progress bar on top. And the chip is burning hot. So removing that LED did not solve anything. The chip is burning hot. If we go here, maybe if I put some alcohol on the chip, the short is coming exactly from this point. If you look at the alcohol, it's evaporating from this area first. Let's take a look one more time. Yeah. What's inside the chip, I do not know. Some suggested that we may have a shorted capacitor inside the chip. That may be true, but we cannot just grind through the chip not knowing where we are grinding and not having a prior experience on grinding a similar chip to know what's inside. I do not want to grind the chip to a point of no return. The customer may still be able to send this over to a specialized data recovery lab and they may be able to help him out further. Maybe they have tools or they know what's going on inside the chip and they may be able to recover data. What if we try this on an iMac? Let me plug this on an iMac and see what happens. And now we're gonna plug that drive in the USB port. And the computer says, the disk you inserted was not readable by this computer. We have the option to initialize, ignore, or eject. We're not gonna initialize. What if we did ignore? What happens? Nothing. The thing right now is that we are getting a different message than last time. Last time we got a non-recognized drive and the drive would immediately disconnect. Whereas now the computer is prompting us to format and the iMac outside is prompting us to initialize the drive. So I do not know what changed. Is it the LED that we removed or is it the socket that we changed? The chip is still the same chip. I want to see if the drive will not be recognized now after we put that LED back. Format. Why are we getting the format message now? What has changed? I desoldered the socket and I was cleaning that chip to put it inside the back to send it back to the customer, and look at what I found. When I tilted the chip sideways, you can tell there's a crack right here. The crack is more visible when the chip is tilted. Look at this. That explains why the drive is not working, and that explains the short inside the chip. So that's it. We're gonna email the customer and let him know what's going on. We're gonna send it back to him, and I hope you enjoyed the video. Let me know what you think, and we'll do something else in the next video.